sailboat because that's all I know how to draw. It's really simple, whatever. And you, what are you doing? 3.2, okay. You start off with 3.21 miles per hour, okay? Miles per hour, this direction, and we know this angle is 62.5 degrees, okay? So, and we also know there is a river current, velocity of the current is going 1.25 miles per hour completely east. Or wait, I wrote this wrong.
No, they drew it wrong. It doesn't make sense.
They drew it wrong?
Yeah.
Okay, whatever. We'll just pretend that their drawing is right because I don't want to draw it again. So, whatever, that's cool. It doesn't matter. Just follow their drawing or follow what, I don't know what to tell you about how if there's a messed up typo in the question. Anyways, so how you handle relative velocity, okay? I might go ahead after I conquer this question to address the concepts afterwards real quick, okay? Oh, we also know, don't we already know that the distance of the river, I already know that, right? Yeah. 0.675. Okay? Cool. So, what we always want to start with relative velocity, is you always want to make the vectors of velocity going comparable directions. What I mean by that is that this current of the river is going straight horizontal. I drew it wiggly, but it's going this way, okay? Horizontal. Angle of 0. Technically angle of 180, but whatever. Going this way. This way. So this guy is going at an angle of 62.5. I can't really compare it to this when it's going at this angle because it's weird math. That means I automatically want to make it into components. I make it horizontal component, vertical component. Make it a right triangle. This is the hypotenuse. How do I handle that? Just in case, just as a review for all of you guys, because we've gotten asked this a lot. This is the angle theta, okay? Making it a little bit more clear. This is 62.5 degrees, and we know the hypotenuse is 3.21. Okay? We want to make this vector into two separate vectors, a horizontal and a vertical, right? How we do that is, I always do it so, alright? Everybody knows this stupid little baby talk for trig. And so basically it's saying sine is opposite over hypotenuse. That means when I have an angle and I have the hypotenuse, the magnitude, then what I want to do is this is the angle. The opposite side of the triangle is what I can multiply the sine by. Because really what's going on is sine of theta or sine of 62.5 is equal to vertical or distance vertical. Alright, distance vertical over 3.21. Oh no, this is velocity. Velocity vertical. My bad. Right? Velocity vertical over 3.21. So I bring this over, and then I know that it's going to be 3.21 times the sine of 62.5, and that is the vertical velocity. So this is 3.21. Sine of 62.5 is this vertical guy right here. And that will be 2.847. Okay? Alright. Now, so that means the horizontal can be cosine of 62.5, because it's just the other one. Is anybody having any trouble with this? Do I need to explain this further? Cool. No, okay, cool. Alright, so then 3.21 cosine 62.5 is 1.48. So these are the velocities. We got 2.847 miles per hour going across the river, and then 1.48 going against the current. Now, how do we deal with this? So we got this boat going this 1.48 to the right. But underneath it is this current making it shift back. So it's trying to go this way, but the ground or the water underneath it, yes? It's supposed to be 62.5. Sorry, I addressed that sorry, yeah, it was a typo. 62.5. Okay? That's the only way this answer is correct. So you have this guy, you have the boat going this speed, and then the ground underneath it. How am I going to illustrate this? Okay. So this is the water. This is the boat. It's going fast. This is going fast against it. So it's still moving forward, but it's moving forward a lot less speedy because the ground underneath it. It's like trying to run on a treadmill. Sure, you can run faster than a treadmill and then crash forward, but it's that kind of frame of thought. So basically, how you handle this is all you do is now that you've made it in the same horizontal component, like they're both horizontal. Now you just find the difference between them. We're looking for that. We have 1.25 going this way, 1.48 going this way. The difference between them is 0.23. So the horizontal velocity is 0.23 miles per hour. The vertical velocity is completely unaffected by it. Is anybody questioning that? No? We're all good with the fact that the vertical velocity is not affected. Cool. So now we have this. We have the vertical velocity equal to 2.847. We have the vertical distance. The times are going to be the same. We're looking for this guy. Right? That's what we're looking for. Right? Yeah. We're looking for that guy. So D equals to VT makes us be able to solve for this T. I have the answer written down. Does anybody want to tell me? Okay, whatever. 0.237 hours. We're still doing everything in miles per hour, right? Because we're given miles and we're given miles per hour. So then now this is going to be hours. That's important. That's why I was talking about units earlier. I'm being lazy and I hate chalkboards, but you shouldn't. Okay, so now bring this guy over here. Use the same equation. D is equal to 0.23 times 0.237. So that's hours, that's miles per hour. We end up with D is equal to 0.0541 miles. This question is asking So, do I need to go over how to change? Oh, I'm sorry. Yes. How did we get this time? Well, we solve for this, right? We solve for that, and we're given this distance. So we have d is equal to v times this time. So what I did was 0.675 is equal to 2.847. Sorry, my handwriting. Times t. And then I solve for t by dividing this guy, 2.847. That guy goes away, so t is equal to that. That's the number. Got it? Yes, sorry. Did I mess up? Did I mess up? No. So any questions? Okay. Do I need to go over how to convert this distance of miles into feet? No.
What would the answer end up being?
The answer she kept it on this way, and it's the way for all the tests. It's always the first answer.